Broadcasting, maybe? Okay, looks like we're broadcasting. All right. It is February 17th. Okay, looks like we're broadcasting. All right.
I am double
It is
broadcasting.
February 17th.
I am
Looks
in
like we're
inception
broadcasting. All right.
mode.
I am double broadcasting.
I am
It
in
is
stop
February
double
17th.
broadcasting.
Looks like we're
Inception
broadcasting. All right.
I am double
It
broadcasting.
is
Stop
February
double
17th.
shift out of
Inception.
stop
February
double
17th.
broadcasting.
Looks like we're broadcasting. All
I
right.
am double
It
broadcasting.
is
Stop
February
double
17th.
shift out of stop
Inception.
I am double
broadcasting.
broadcasting.
All right. That's ugly. Always ugly to get started. Here we are. Okay. So we ran through a bunch of stuff to get us started. I'm working on getting our attendance set up. Still owe you some grading. I apologize. I did not get as far as I wanted to yesterday. We had some items come up. Our friend who was who's in the hospital had a successful surgery. They're trying to repair her vocal cords, and we're waiting to hear how that is going. But it seems like we're out of life-threatening stage, which is wonderful. Let me open us in a word of prayer to get us going. Father, thank you for our we have an opportunity to learn, that we have an opportunity to put our gifts to use. Help us not take our time for granted, and help us to steward our time well. Help us to remember that in you we live and move and have our being, like ancient Cretan philosophers said long before the New Testament. Amen. Okay. What we need to do is we need to make sure that we have Eclipse set up now, and I have got Eclipse set up. I'm broadcasting on Eclipse. I have not connected yet to Saros. Let me connect to Saros for us. And let me set up a class for today. New project. And today it's going to be class 16, and it's going to be 0217. Next. All right, I've got that set up. While I'm still connecting, while I'm doing that, I'm going to be shifting my project so that I've got JUnit testing in there by going to Project, Properties, Java Build Path. You guys don't need to do this because when I share it, it should show up. I'm going to add the JRE system library to my class path, not my module path. I'm going to remove it from my module path. I'm going to add a JUnit library to my class path. I'm going to apply and close, and I'm going to make a sample class just to make sure that everything is working smoothly. I'm going to call it Hello World. I'm going to give it, I'm going to spell it right, world. I'm going to give it a main. I'm going to ask Eclipse to generate that for me. Eclipse has generated it. I'm going to do system.out while my fingers warm up. Println hello world. All right, I'm going to run that. Looks good. And it's running okay. Hello world. Great. All right, so now as I wait for my connection to work, there we go, everyone's up. I'm about to share my very simple package with you so that we can get on talking about loops. All right, I'm sharing my project. It's class 1602 to everyone that's currently online. Here they go. All right. All right, looks like Adeline, looks like you're okay. I'm gonna give everyone a second here. Ben, looks like we need to reshare with you. Let me let some of these synchronize. For those of you who are connected, let's just go crazy. Why doesn't everyone add something to the main method so that it will, in addition to printing out hello world, it'll print out your name. So add a line after line 5 that prints out your name. Let's just do a mass edit and see what happens. So go ahead and edit hello world so that you add your name to the systemout.println. Yeah, maybe that's how we'll do. That's how I'll do attendance. I'll capture everyone's name in the main method here. Okay, a few more people arriving. All right, I'm going to go through a second pass here. Trent, adding you. Morgan, adding you. Faith, adding you. If it's not working, try restarting your Eclipse. Ethan, adding you. Carson, adding you. Ben, adding you. Let's see what's going on here in chat. All right, it's just for reference, are you all seeing a bunch of messages in chat from something called Name Rotator? That is the appliance that I've sort of built for capturing attendance. I'm not sure if that's being broadcast to everyone though. Yes, okay, I will eventually fix that then. All right, for realsies on attendance, I'm also capturing who's present in the nearby list. Okay, got that. And then heading back to Eclipse. Everyone is sort of editing on top of each other, it looks like. Let the current synchronization finish before I go through and start trying to correct things. All right, that does not look like it's going very smoothly, so I'm going to go through and I'm just going to start making everyone. Hi, Adeline. The editing's not going very well, so I'm going to switch everyone to read only. Okay, Adeline going to read only. Ben Fernberg going to read only. Ben D going to read only. And so for those of you who are concerned about participation today, I captured it with a screenshot of who's in game right now. Carson going to read only. Ben A going to read only. Ben D going to read only. Frank going to read only. Landon going to read only. Monty going to read only. Matthew going to read only. Sam going to read only. Thomas going to read only. And let's do one more pass of inviting people. Ethan Vaughn, I'm adding you. Ethan Banez, I'm adding you. Faith, I'm going to try and add you. Josh, adding you. Dee Dee, adding you. Morgan, adding you. And then Trent, adding you. Okay, go through and do a read-only pass. Ethan Vaughn, you're going to read only. Ethan Banez going to read only. Josh going to read only. Morgan going to read only. Trent going to read only. And let's see what else we got. We got, let's see, Morgan, looks like you're on there. All right, Dee Dee and Faith, I'm not sure what's going. I know Faith, you've got some trouble with your home internet connection. Something's going on there with the bandwidth, so we'll see if we can add you one more time. Dee Dee, I'm not sure what's up with your connection. right. All right, people are coming and going, dropping and adding. All right, we'll let it go at this point. Maybe if we get a chance, we'll try again, add some other folks in a sec. What I want to do is I want to revisit our loops. Let's just take a look at our loops from last time. I'm going to go ahead and copy our loops class from our last class and drop it into this session as well. There we go. I'm pasting it in, and I'm going to go ahead and get rid of hello world because I don't really care about that. And let me make sure that that's sharing. Okay, it looks like it's sharing okay. And if we go into loops, we can see that we've got a variety of different loops that are present here. There are three primary loops that we are interested in Java. We see them represented here as being the while loop, that's at the top. And we've got the for loop, and that's in the center. And we have the do while loop that's at the bottom. Let me see if I can zoom us in so we can see that a little bit better. Okay. Those are the three looping structures that we use primarily. There is also a fast enumeration, which we haven't seen yet, but that's also that's used once we have collections. And since we haven't introduced the idea of collections yet, we're not going to introduce the idea of fast loops quite yet. Okay, so we were talking last time about an investment problem and how we might do that investment problem. Let's go ahead and see if we can pick it up with the for loop then. Let me see if I can get us there. Okay, this is giving me a little trouble. Let me see. Okay, let's see. I'm having a little bit of trouble here. Let me see if what I'm going to do is rather than working with slides, I'm just going to grab some code for us, and I'm going to put the code into our environment. And in order to do that, I need to be able to access my terminal. I have a terminal window open. I'm now going into our class resources, and my windows are jumping around, so it's hard to keep track of where I'm typing. Okay, I've jumped around again. And let's move into this class. And let me go into my, jumped around again. Okay, and let me find our class here, today's code. Okay, I've found the code. Now let me navigate to it. And let me pull it up. All right, I have the code in front of me. I'm now getting it as text. And now I'm moving it into our class that I'm sharing right now by creating a new class, and I'm waiting for Eclipse to respond. Eclipse is not responding. There we go, Eclipse is responding. Got a new class, and we're going to call it investment. And we're going to share it. All right, now I'm going to put some code in there. All right, so let's take a look at what we've got. It's a class called investment. It's a utility class. It's a class that we are going to use as part of a application, but this is the implementation. So we're also going to need the implementation. So let's get the implementation. And actually, I think it might be easier to start by looking at the implementation and seeing how we're going to use that in the context of this class. All right, so I'm going to call this investment runner. All right, and I'm going to save it. All right, you should see this okay. So investment runner is like our app. We're going to run this app. You can see that there is a main method. The only thing that this class does is to run the code that's present in its main method. We identify the main method as being static, which means that it's not able to use any of the private methods or any of the instance variables of investment runner. A static A static method is, or static variables, are just variables that are stored in in a particular object, in this case investment runner, and you have to create an object if you want to use any of the internal classes. Now there are no any of the internal methods. There are no internal methods. There are no instance variables in investment runner. All we're doing is we're using this class in order to run our code that tests or utilizes our investment class. And so what we're interested in is we're interested in knowing how long it's going to take for an initial balance that is in a bank account that is getting a 5% rate of return to double that balance using the principle of compound interest. The principle of compound interest means that after 1 year or after whatever amount of time we're compounding interest on, we'll have more than we started with. So in the case of an initial balance of $10,000 and an interest rate of 5%, after 1 year, we'll have 5% of $10,000, which should be $500. And so the second year, we'll start with $10,500 and we'll get 5% of that, which is going to be higher than 500. And so the amount of our principal grows and grows and grows. That's the whole benefit to a consumer for saving with a decent interest rate. The way we're going to implement this is we're going to create some constants in our main class. Our initial balance is going to be 0. This is listed as a double. We actually are using an integer literal here. So if you see here, there's no floating point. There's no decimal point, and so Java is treating this as an integer literal. And then when it assigns it to a double, it's doing a conversion from an integer literal to a double. I don't actually like that, so I'm going to go ahead and force it to be a floating point literal so that there's no conversion that's happening. I'm using snake case and capital letters for the variable name initial balance in order to indicate that indicate to a programmer that it is a constant. But to indicate to Java that it's a constant, I'm putting the modifier up here, final. And that means that I cannot change the value of this variable after it has been initialized. And I will have some support from that from the programming language, because if down here I try and set my initial balance to something else, I'll get an error because if I hover over here, the final local variable initial balance cannot be assigned. It must be blank and not using a compound assignment. What that's telling me is I've already assigned it something, and so I can't assign it a value. If I have not assigned it yet, I'm allowed to assign it one time, and after that, I'm not allowed to assign it anymore. So you can see that by giving it the final coloring there, you're allowed to assign it one time and no more. That's to enforce within the language the idea of a constant. All right, similar thing happening here with rate. We just have to be careful about our units. And what we're going to do now is we're going to use our object called investment, and we're going to call the constructor, which we haven't defined yet, with the initial balance and the rate that we're interested in. That constructor will create an object and will return a reference to it called invest. Invest is now an object of type investment, and within it, it has the information that we passed in within the constructor because it only has that because the constructor is going to save it. We'll look at that in a second. One of the methods that we provide as part of the public interface for invest is a method called wait for balance. And what wait for balance does is it internally calculates how long it's going to take to reach this balance, or 2 times our initial balance. It doesn't report anything. It doesn't return anything. You can see that it's just calculating that and storing it somewhere inside the object. And if we want to know what the answer to that is, we have to call yet another method called getYears. There are different ways that we could decide to architect this object if we didn't want to have it such that wait for balance changed something internally as a mutator, such that later we had to get years. We could also have wait for balance return the result. But for whatever reason, we choose this way of implementing it. When we do get years, we get back a value and we store it in a primitive integer type called years, and then we output the result here as a result. All right, let's go ahead and run it, see how it goes. I'm going to run it with coverage so we can see which lines get run. We'll see down here on the console if I'm broadcasting that okay. Okay, you can't see on the console. Let me scoot that up. All right, you can see that down on the console it says the investment doubled after 15 years. All right, that's interesting to know. If this is correct, and we would expect that a higher rate of interest would double our amount faster. So let's change that to 7% interest rate, and let's run it again and just see what happens. See that with a 7% interest rate, our initial balance will double after 11 years. All right, so that seems like it's working correctly to some degree. That's at least a gut check that our code is all right. As we increase our interest rate, it takes less time to double our value. So now let's go into our investment class and see what it is that we are doing when we call our constructor, when we call wait for balance, and when we call get years. So I'm going to do something here that is very helpful in Eclipse. And that is I'm going to hit, let's see, what do I do? It's muscle memory for me. Let's see, not that. So for me, it is, on my computer, it's a hotkey is F3. F3 is not two keys you hit, it's one key. It's one key that's labeled F3. It's typically at the top of your keyboard. Sometimes if you have a touch bar Mac, it doesn't show up because it's on this little touch strip at the top, and you have to hit the function key before it shows up. But wherever your cursor is, when you hit F3, or alternatively, you can right click on it and go down to declaration. I'm sorry, reference? No, what do I want? Declaration, yeah. Why is that not showing up? It should be under declaration. I guess I can open declaration here. This shortcut open declaration will jump me to where that particular method or class is declared. And so it jumped me to another file. It jumped me to the investment file here, and I can look and I can see what it is that the constructor does. The constructor must be passed in a balance and a rate. You can see that the constructor doesn't return anything here. It doesn't even have void. That was a mistake we made during office hours with one person that stopped by. It doesn't have a return type because the return type of the constructor is a reference to the object itself. So the way that we know this is a constructor is because of two reasons. It has the same name as the class in which it is contained, and it also has the same name as the file in which it is saved. And so you can look at that at the tab. And it doesn't have a return type. And as a result, this is considered a constructor. Constructors technically don't have to be private, don't have to be public. There are some instances where private constructors make sense, certain patterns, but not this one. So we have one constructor. We must call this constructor with an initial balance and a rate. And you can see that in our Java doc up above, our Java doc indicated on line 11 with a slash and then 2 stars. A description that this constructs an investment object from a starting balance and an interest rate. And then the starting balance is our first parameter and the interest rate is the second one. Our constructor only initializes our instance variables. This is typical and a recommended best practice. We have 3 instance variables. They're declared within the class, but outside of any method. That's what makes them an instance variable. If we had taken these 3 variables and we had put them inside our method like this, they would no longer be instance variables. In fact, they would just be local variables, and private doesn't make any sense for a local variable. But we could do something like this. That's fine. It's fine if you want to declare some variables like that, but they're not visible once you leave the method. Once you leave that method, you don't have access to them anymore. They go away. They're ephemeral. They're temporary variables. They're temporary local variables, as all local variables are. If you want the values of the variables to stick around after the execution of the method, whether that method is a constructor or otherwise, you have to put them in a higher scope. You have to put them out here. You have to put them in the class, but outside the method. And now that I have them as part of the class, it does make sense to declare that they're private because users of the class should be prevented from having access to them. Now you can see that I've left the declarations on 19, 20, and 21, and that's a problem because what it means that with 2 declarations of those variables with the same name, for example, on line 7, I have an instance variable declared that's called balance. It is a private double. And I have also a local variable declared on line 19 called balance. And what's happening is the local variable on line 19 is shadowing or blocking the access to the variable on line 7. So on line 22, when I say that balance is equal to a balance, the parameter that's being passed in, what is getting set is this local variable. And so when my constructor is over, that local variable will go away, and I will have no record of what the constructor was called with. You might think that it was stored in 7, but it wasn't because I have a local variable that's blocking this. So 2 things that I could do to avoid this blocking. I could just delete the variables on 19, 20, and 21 because I'm not using them. Alternatively, I could use the this keyword in order to be very explicit that the version of the variable that I care about is the instance variable. This bypasses any local variable and immediately goes to line 7, 8, and 9 and stores the information there. Now, of course, 19, 20, and 21 aren't being used for anything, so we can just get rid of those. But let me show you one more super complicated thing that could happen. It's possible that you could also call these variables that are, these parameters that are coming in, the same name. And this is confusing because now we've actually got 3 different variables that are all called the same thing. And they're all shadowing and blocking one another. So for starters, on line 19 and 20, I'm not allowed to create a local variable called balance and rate because I already have a variable in this scope called balance and rate. It's coming from the parameters. So line 19 and 20 are giving me an error, and I can get information about that by hovering. It says a duplicate local variable balance. The duplicate is with the parameter. On top of that, down here on line 22, I'm not accessing the instance variables at all. A very common pattern, and one that I think is very clear and I would recommend, is to use the same name in your instance variables as you do in your constructor for your instance variables. So let me type this in right, balance and rate. There is some confusion here because you do have 2 variables with the same name. You have the variables that are named from your parameters, and you have a variable with the same name in your instance variables. But what you can do is you can do this dot balance equals balance, and this dot rate equals rate, and you can say this dot year if you'd like in order to set it equal to 0. And I feel like this is a very clear programming style that makes it obvious what the relationship is to the variables in the constructor on line 17 with the variables that are being stored in your class on 7, 8, and 9. And the way that we make sure we get the behavior that we want is we include the this keyword on 19, 20, and 21. At the end result, that's trying to scope out, that's trying to give you some of the ways in which this particular method works to handle that. But at the end of the day, all it's doing is storing what the user has passed in as the balance and the rate and doing nothing else, and then immediately returning. It's also initializing year to 0. So if we go back to our investment runner, what I want to do now is I want to use the debugger feature of Eclipse. Many of you resist using the debugging feature for some unknown reason, but it is common for new programmers to not use the debugging feature, which is too bad because I feel like well, one reason why is because it slows you down, and often we have this sort of internal panic that I think is actually generated by the world we live in that causes us to want to just hit refresh and redo and research and Google search and never slow down and think about what we're doing. So what I'm going to do is demonstrate how you can use debugging to step through this code as well. On line 12, I'm going to add a breakpoint. And I do that by double clicking or right clicking on the line number, and you'll see a little blue dot show up. Let me make sure that's showing up okay on the broadcast. Yeah, you can just barely see it. And when I run my class, I'm not going to run it as a Java application. I am not going to do coverage as, I'm going to do debug as. 3 different ways I can execute my program, and then actually you could do JUnit testing if that was a JUnit test as well. But so that that breakpoint matters, so that my code will stop when it encounters that breakpoint, I have to execute my program in a different way. I have to execute my program with this debug as method. And when I do that, it's going to run my program more slowly because there's a lot more work that the Java virtual machine has to do in order to keep track of what line numbers we're on, in order to keep track of what the variables are so that they can show it to me as a developer as we're in process. So the debug process is slower. I mean, it's not slower in human speed. We're not going to notice a difference, but it's slower in terms of the maximum speed at which the computer can run at the benefit of being able to show us a lot of information. So I'm going to debug it as a Java application, and we're going to switch views when that runs. Let's see how we're broadcasting here. I want to make sure we're broadcasting clearly. Okay, and I'm going to switch to my big screen view at the risk of that being low resolution. There we go. All right, and I'm going to have my camera go away briefly. No, I'm just going to lower my camera if I can do that. Let's see if I can do that. Where do I want my camera to show up? There. Okay, there we go. All right, so as I run this, the first thing I notice is that my program is running. I've switched to what's called a debug perspective or a debug layout. All of my windows have changed to support a different way of looking at my code. If I want to get back, on the upper right, there's this Java button and debug button. This controls the different kinds of perspectives that I can look at. If I want to go back, I can switch to Java and click there, and I'll go back to the way I was looking at things. Or I can go back to my debug view by clicking here, and I'll go to my debug view. You can customize this pretty richly if you want to customize your perspectives by looking into that button and sort of exploring how you can lay stuff out. When I'm in the debug view, I get a bunch of different things that are going on. I have the code here, and you can see that it's the highlighted green indicating what line is about to be run. In the upper left panel here, I see a breakdown of the currently executing threads. A thread is like a process that's running. It is the Java virtual machine running my program, and it's highlighted right here. This particular thread is currently on line 12. So if I click on this, I can see that line 12 is indicated up here. And as I look down here, I can see that line 12 is highlighted. So these two things are in conjunction with one another. Up here, I have a bunch of information about what the current setting of my variables in scope are. In this particular scope, I have one called rate and one called balance, and you can see that the values are there. And over here, I can add expressions if I'm so interested. So I have one that's left over from debugging I was doing on a different program. And you can actually add complete expressions here. So I would like to add a new complete expression that would be calculated anytime the program stops. So, I can say, what is invest dot balance? Let's see if it'll let me look at that. It's not letting me look at that. Why? Oh, because I don't have a variable called invest yet. But what I'm going to do is I'm going to go ahead and leave that there. Because I haven't run line 12 yet, there's no variable called invest, and so I'm getting an error. So let's just add one here just so you can see what happens. I can actually do let's say I can ask what initial balance times rate divided by 100 is, and it'll calculate that for me, and it'll keep that up to date as I run. And then down in the bottom left is the console, whatever I'm taking input and output from. Now what I'm interested in is now that I have stopped my program, I want to run my program slowly so that I can watch what's happening. And there are different ways in which I can step through my program. I can follow a function call and go into a method or a constructor. I can step over a line and go from 12 to 13, allowing my constructor to run. And I can go step by step, or I can let the program go at full speed again. All of those buttons are controlled up here at the top. They've got three different buttons here. I can run. Oh, no, sorry, that's the wrong one. Over here, these little arrows, yellow arrows. I can step into my program. I can step over my line. I can use more complicated logic to do that if I want. I know that my program is running because right here I have a thread indicated in my debug panel. I also know it's running because I have a red square lit up here at the top, and I have a red square lit up down here in the console. If I hit the red square, it's going to stop my program running. I'm not interested in doing that right now. What I'm interested in doing is stepping into my constructor. So I'm going to hover over this to make sure that I'm stepping into, and I'm going to click that button, and I'm going to step into the constructor. And you can see that I didn't actually step into the constructor. I stepped into some other weird system function here. There's some methods that get called on your behalf by the Java virtual machine, and this is called a class loader. And if you ever end up in a position where you're not sure what's going on, like how did you get here, there is also a debug button that takes you back out of that, allows that method to finish running, and then stops when you return from that method. So I have stepped into this class loader, and now I'm someplace I don't want to be, so I would like to step out of that class loader without losing my step-by-step processing. And so the third button here now is step return. It will continue running until you return from this method. So I'm going to click that, and now I'm back where I was, having not actually run my constructor yet. So now I'm going to try that again. I'm going to step into my constructor using the step into button, and now I'm at the code that I expected to be at, line 17. You can see that up here in the upper right, where in my variables, I have some new variables in scope. I have a local variable, and my parameter balance is in scope, rate is in scope, and I have a reference to this that is in scope. And if I open the accordion expander here, you can see that this is a reference to an object. It is of type investment over here on the right. And in there are three private instance variables whose current value are 0, 0, and 0 because that is how Java initializes those primitive types. I now want to step over line 17, but I don't want to there's nothing to step into. So I'm going to step over that line and go to 19. I'm going to watch in my variables to see as how 19 changes. I'm going to step over that, and you can see that it gets highlighted yellow to indicate that it changed since my last step. The instance variable balance has taken on the value of the parameter balance along the way. So I'm going to continue stepping over lines. Now I'm going to step over 20, and I'm going to step over 21. And I'm going to see that my instance variables have all been initialized. I could now either use the step return, which will return me from the constructor, or I can step over this final curly bracket, and they're both going to have the same result. I'm going to return from where the constructor was called. So I'll do step over. And now I'm back at line 12, having returned from that call. And now I'm going to take the result of calling new investment, and now it's going to be assigned to the invest variable. I had to evaluate the constructor first, and now it's being passed over to invest. So I'm going to step over this line, and you can see on the upper right here, now I have a new variable, which is a reference to an object called invest. And internally, I have three instance variables whose values are 10,000, 5, and 5. And you can see that my expressions on the upper right are now evaluating correctly, because now that there is a variable called invest, I can look internally into it to see what the balance is. It's allowing me to do that because I'm acting as a developer right now, and so I'm allowed to look at private instance variables as a developer. Now I'm on line 13, ready to call the wait for balance method. I'm now going to step into that to see what happens. I'm going to use the step into button. We're going to go into our invest class, and you can see our loop, which is the point of our chapter this week. We're going to run a while loop. We're going to be using balance as one of our controls in our conditional, and we're going to use target balance as one of our controls in the conditional. Target balance is what was just passed in when we called this method. And if I want to know what it is, I can look up here and see my variable. Oh, it's 20,000. And that makes sense because that was initial balance times 2. My variable balance, where is that? Well, that's the private instance variable balance. And so I can see that that's 10,000. And I'm going to continue running this loop until our balance is no longer less than target balance. Because remember, a while loop is like an if statement. If the condition is true, we're going to run the contents of our 32 to 36. And then when we're done with 36, we're going to come back up and we're going to evaluate 31 again to see whether or not we should run our loop again. So because we evaluate first on line 31, our loop may get run 0 or more times. But it will the conditional will get evaluated for sure. All right, if we look at this, balance is 10,000 and target balance is 20,000, so we better go into this. This isn't a method call, so we don't have to step into using our buttons here. Step into is just for stepping into a method call. Step over stays within a method and just moves to the next line. So we'll move to our next line. We'll increment year by 1, and we'll see that's reflected in the yellow highlighting in the upper right. We will calculate how much interest we made by taking our balance and multiplying it times our rate divided by 100. So make sure our math and our units are okay there. I will step over that line, and you can see that interest is a local variable. It is not known anywhere outside of the scope of this particular while loop. We're just using it temporarily to store the amount of interest that we earned in the first year, which you can see was 500 by looking in the upper right. I now want to change my private instance variable to be incremented by the amount of interest I just made. So I'm going to step over that line, and you can see that my balance has updated to 10,500. I still haven't doubled the number of the amount of my balance, and so I'm going to continue running this loop, incrementing the year, calculating a new interest. Remember last loop, the interest was 500, but this time the interest is 525 because we're compounding our interest. It's getting higher and higher. My balance is going to be increased by this additional amount of interest. I'm going to step over it. My balance is now 11,025. I'll continue running this loop, incrementing my year, calculating my balance, incrementing my balance, evaluating my current balance, incrementing my year, calculating my balance, incrementing my balance, checking my conditional, year, interest, balance, conditional, year, interest, balance, conditional, year, interest, balance, conditional. We know we're going to end up running this about 15 times based on the result we did during our training. I'm just going to go ahead and run it 15 times. Who cares? All right, year's 10, year's 11, year's 12, year's 13. I want to be careful in the last one. All right, so now my balance is 19,799, not quite greater than my target balance. I'm going to step over and simulate another year. My year is going to get incremented to 15. My interest is now, for this year, $989 and a bunch of change. I'm going to increment my balance by that amount, and boom, my balance is now greater than my target balance. I evaluate line 13. Is balance less than my target balance? No, it's false. And so I'm going to skip the loop starting at line 32, jump over that to line 37. I'm now at the end of my method, and I will return from my method. My method returns nothing. You can see that on line 29, it returns void. So as a result, wait for balance is not actually going to return anything to the caller, but what it has done is it has mutated the state of the object. The value of balance has changed. The value of year has changed. And although we set interest to a variety of different values as we were running the loop, because that was a local variable, it is going away now. As soon as we return from this method, the interest variable is no longer known. In fact, the interest variable is no longer known even now because we're outside the scope of the curly brackets that run from line 32 to 36. In Java, local variables are only known within the smallest scope in which they're defined. And that scope is usually bounded by curly brackets. And so the interest variable isn't even known outside the curly brackets within the method. It's very, very local. Let me stop for a second before I return, see if you have any questions about the way the debugger is working or what we've seen here in the object. I've been going at sort of Mach 2. Let me just pause and see if you got any questions or comments. All right, double broadcasting, are we okay? Okay, then let's keep rolling. We return from wait for balance by using either step over or step return, and we're back. We're back on line 14. Sorry, we're back on, we completed line 13. There was no more work to be done because we evaluated line 13. We didn't have, thank you. I figure if 1 is good, 2 is better. I figured wrong. Okay, line 13 is complete. Wait for balance is done. We've evaluated line 13. There's no more work to do with the result, that void result. Now on line 14, we're interested in seeing how long it took for us to get to that balance. So we're going to call get years. I'm going to step into that code here. Oh, almost hit the wrong button. I'm going to step into that code. We're now back into our investment class, and the only thing that get years is doing is giving us access to the internal variable year that was set by wait for balance. It was set by wait for balance. We want to return it. We're just going to use this as a mechanism for returning it. So we return an int and we step over that line. Now on line 14, invest.getYears was evaluated. It has been turned into the value of years, and now we're going to create a local variable in the main method called years as well of type integer, and we're going to assign it that value. Step over that, and you'll see that this new variable shows up in the upper right. Its value is 15, and now we can print it out. Step over the system outline. You can see that we've printed out to console. We're on line 16, which is the conclusion of the main method. My program is still running because I have my red boxes lit up. I'm going to step over this line. The program is now concluded because that was the final line. You can see that everything in all the threads up here have been disconnected and or terminated. You can see my red boxes are no longer highlighted. And so we have run the program, seeing how our while loop executed. All right. I'm going to switch back to my Java perspective now. Any questions or comments about that? All right, I am now going to move into a slightly different and more complicated example of a way of using our loops. And what I'm going to do for that is I'm going to introduce something called a Monte Carlo method. And what a Monte Carlo method is basically a simulator. And it's named Monte Carlo method because it is named after the locale Monte Carlo, which is famous for its casinos. But you'll find that the Monte Carlo method is often used in computer sim you know, when do we use it? We use it in places where we don't know how to calculate exact answers to problems, and instead we are interested in trying to come up with simulated answers. Um, so what we're going to do is we are going to use the Monte Carlo method to try and calculate pi. Let me just see. Okay, Matthew, I see that you said all on green. Oh, got it. I was like, what? Lines are green? I don't know what you're talking about. Matthew's all in. That's great. I now know what paper hands and diamond hands mean, and so like I feel educated. But what we want to do is we want to run a Monte Carlo method in order to simulate the value of pi. And the way we're going to do that is by throwing a bunch of simulated darts at a board. And so we can imagine that we have a dartboard and it's on the Cartesian coordinate plane, and it is bounded by -1 and 1 and -1 and 1. And so what we're going to do is we're going to pick a random number, two random numbers that put us within this square, somewhere between -1 and 1, -1 and 1 on the x and y location. And we know something about the nature of circles. We know that if we have a circle, we know what the area of that circle is. We know that the area of the circle is pi r squared. And so we know that the number of dots that we throw at number of darts that we throw at this dartboard, some of them are going to fall in that circle and some of them are going to fall in the square but outside the circle. And by examining what the ratio is of those two numbers, we can come up with an estimate of pi using the Monte Carlo method. And again, the Monte Carlo method here is because we're choosing random numbers to do that. So our estimate for pi is going to be it's going to be 4 times the number of things in the circle divided by it's 4 times the number of things in one of the quadrants. So it's the number of hits divided by the number of tries. So we're going to generate our random number using our random number generator function called next double. We've used next int when you did your die generator, your die simulator. We're going to use next double, which will give us a number between 0 and 1. And we're going to create an x value from that. We're going to modify it so that we get a number between -1 and 1. And then we'll use that in our code to try and calculate what pi is. All right, so let's take a look at that in the context of our program. Let's create a little program that's going to do that. So I'm going to create a new class, and let's call it Monte Carlo. Let's call it Monte Carlo Pi. Let's make a main method. And this is mostly just going to be a script. It's not going to be, and like I can zoom in a little bit here too. We're not going to use much about object-oriented programming in order to make this work. We just are going to use the random number generator and loops in order to make it work. So this isn't really an exercise in using objects. This is an exercise in doing a Monte Carlo simulator. All right, so the first thing we want to do is we want to pick how many darts we're going to throw at the board. Now, ultimately, we want an infinite number of darts because we want to calculate the area of the circle divided by the area of our square. But we're not going to get an infinite number. We have to get some large number. So someone out there have a number that they like, somewhere between 1,000 and 1,000,000. Shout it out, and you'll be the person that wins. Million. All right. I'm going to use this underscore notation, which is something you don't see often, but is helpful for. Now I think you're a double broadcast. Am I double broadcast? No. Okay. Wow, that was weird. Okay. Why? Why do I hear myself? It, it's, let's see. I don't know who answered, but were you live, Mike? Is that why? Were you live, Mike? Is that why I could hear myself? Don't know what's going on. Okay. Back to YouTube. Okay, so we've got the number of tries we're going to do. That's going to be 1 million. And we need a random number generator so that we can make our numbers each time. So we're going to create one object, which is of type random. We'll call it generator. And we will call the constructor for the random number generator class that does this for us. That is something that's built into Java, and we still have to import it, however. So I'm going to use Eclipse to help me out. I'm going to do a quick fix, and it offers to import random from java.util or random from some other package in the JUnit test class. I don't know what that one's about, but I do know I want the standard one. So java.util is the standard package, so we'll get that. All right, now I have a random number generator, and so if all works well, I should be able to do out. Here is a random number. I'm not going to worry about my typo right now because it's just a test. Generator.next double. All right. I've got some typo there. What's going on? Too many parentheses. Okay, good. And now I'm not using tries, so that's getting highlighted. And I'm going to run this as a Java application. And down on the bottom, we should see the result. Great. And so we have a random number with between 0 and 1. Because if I hover over next double, I can see what the Java doc for that is. Here's another reason why Java doc is really great, because if you comment your classes with Java doc, when you hover over a method, Eclipse knows how to format Java doc in a tooltip like this. So what we're looking at right now is the Java doc from next double. And it says returns the next pseudo-random uniformly distributed number between 0 and 1. Great, which is what we want. Okay, so now we need a loop, and that loop is going to go through and throw a bunch of darts. So we'll say our loop is going to go from some number, and we're going to use an index variable I, which is sort of traditional, and we'll start at the number 1, and we will continue while I is less than or equal to tries. And so that should execute 1 million times. The first time it goes through the loop will be 1, and the final time it goes through the loop, it will be 1 million. I could equivalently start at 0 and go less than tries, in which case the first time through the loop would be 0, and the last time would be 999,999. Yeah, let's just do this for this time. All right, now that we are inside our loop, we want to throw a dart. And the way we're going to throw a dart is by trying to pick a random number on our X and Y axis. So let's pick a random number from our random number generator. All right, we'll call that, that's going to end up being X, and that's going to end up being Y. We want two different random numbers. Each time you call next double, you get a different random number. And then we'll say that our X value is going to be equal to, we need a number between -1 and 1. So to throw at our entire dartboard, next double gives us a number between 0 and 1. So what we're going to do is first we're going to say, let's transform our random number to, instead of being between 0 and 1, let's make it equal to be between 0 and 2. And then let's subtract 1 from it. And so now it's a number from 0 to 2. And when we subtract 1 from it, it's between -1 and 1. And we'll do the same with Y, just making sure that we switch this to Y. So now we have an X and Y position that's between -1 and 1. Now we need to check whether or not that random dart, so let's put a comment here, throw a dart at the board to a position between -1, let's see, position on a square from -1, -1 to 1, 1. All right, now we need to know whether or not that throw was within the circle. And the way we know whether that throw was in a circle or not is whether the distance from where the dart hit to the center of our coordinate system, 0, 0, if that's less than or equal to 1. If it's less than or equal to 1, then we know we're in the circle. If it's greater than or equal to 1, if it's greater than 1, we know it's outside the circle. And we know what the distance formula is. The distance formula is going to be the distance between 2 points is generally x2 minus x1 squared plus, sorry, let me get that right, y2 minus y1 squared, and then we take the square root of that, and that's the distance. All right, that's not code though. That's just a helpful formula. All right, so we can shorten this, but let's start by doing it formally. Math.square root, and we're going to do the square root of so x2 in this case is just x, and x1 is 0 because we're looking at the distance from the origin. And y2 in this case is y, and y1 is 0 because we're looking at the origin. And we're interested in the square root. We are, however, interested in whether the square root is less. Let's see, why is that not? Let me just put that in the context. Okay, if this is the case, then we're going to say hit plus plus, hits plus plus, hits plus plus. We don't have a variable called hit, so let me add that up here. Initialize it and set it equal to 0. All right, and what do we got going on here? Too many parentheses. What is Eclipse telling me? Operator is undefined for the argument of type. Oh, okay. Let's do math.power. All right, and we need one more. All right, what's it telling me now? Says cannot convert from double to Boolean. Oh, because I'm just asking if math.square root, and that's not a Boolean. I have to put that in conditional. So if it's less than or equal to 1, now it evaluates to Boolean. Great. All right, we can simplify this a lot though. So obviously we don't need our minus 0. Oops. And we don't have to do a big old function call. We can just say if x times x plus y times y is less than 1. And if we square both sides of our inequality, the right side is 1, and the left side just gets rid of the square root. So we can just make our expression this. All right. We'll run that a bunch of times to calculate how many hits we've got. And then to estimate our pi estimate, it's going to be 4 times, because of the way area is calculated, 4 times the number of hits divided by the number of tries that we had overall. So the ratio of hits to tries times 4. And then we'll do system.out.println estimate. Well, actually, I kind of like printf better. Just kind of a thing for me. Printf after %d tries, pi is estimated at %f slash n, and then we'll fill in that with tries and estimate. All right. All right, questions about that before we run it and debug it and see how it works? All right, let's give it a shot. Let's run main. You can see we're not using anything about object-orientedness. We're just running some code in a static method. Let's see how it works with a million tries. What do we get? Pi is estimated at 3.14. That's pretty good after a million tries. Uh, let's do some other fun things. Let's every time in our loop, instead of just calculating our estimate at the end of our loop when we're done with all of our tries, let's put our estimate inside our loop so that every time we throw a dart, we'll see how our estimate changes. So we're going to get a million lines printed out now. Let's go ahead and see how that works. That's going to slow down our computer, but what we'll see is we'll see the evolution of pi. There you go. Oops, hang on, I'm going to stop that because we're not getting quite correct. Let's see. First of all, it's not after tries, it's after I. So I'm going to replace, let me put this down here and comment it so we have it available to us. We need it back. All right, so after D tries, well, we're not done with our loop, so it's just I tries so far. And likewise here, we just divide it by I because we haven't done our full tries set. I, an estimate. Okay, let's try that. All right, there you go. You can see the estimate to pi is growing higher and higher, getting closer to 3.14159. As we throw more and more dots, it's going kind of up and down around the actual value of pi. And as we get the law of large numbers, it should start to average the correct amount as we get higher and higher and higher. As we get closer to a million. And what would be kind of fun is let's see how close we can get to the formal estimate. Let's do one more tweak. And rather than saying, we'll say the differential is, and we'll say it's the math.absolute value of math.pi minus estimate. So what we're going to see is we're going to see how different our estimate is from the most accurate version of pi that our program knows about. So I'm going to hit, we're done. I'm going to clear my console and let's try running that. And so this number should go to 0 as we get more and more accurate. So this gives you a little bit better sense of how close we're getting as all those numbers fly by. And as the numbers get bigger and bigger and bigger, you should see more and more zeros going down the side. Okay, this is all right. This is me getting OCD now. All right, so let's put 10 digits of precision here. 10.9, 9 digits of precision past the decimal point, and let's go up to 10 million. And this will be our last run, even though I'm OCD and want to keep working on this forever. And you'll see that our zeros are getting lower and lower and lower as we get closer and closer and closer to the estimate of pi, but it's a random number generator, so it's a Monte Carlo simulation. And so over time, our variance should decrease as we get closer and closer to the correct answer. You can see that our numbers should be getting smaller and smaller and smaller. There are a few details about the way numbers are represented in computers that cause this to not work out perfectly, but you can see generally what's happening. Okay, so that brings us to the end of our time. 3 different loops that you need to be familiar with. A particularly interesting way of using our loops is in a Monte Carlo simulation, where we run a loop over and over and over again, and each time in our loop we simulate some kind of event that we're keeping track of statistics on, because we know that if we had infinite number of runs, we would have the correct answer. That's all I've got. I will switch over to game for any questions you've got. I took a screenshot today for attendance based on in-game participation, and I'll try and get our attendance board fixed as soon as I can. My rotations got messed up, among other things. So thank you for your attendance. I will see you on Friday. That's right.